electric field due to a dipole on its equatorial point. First, let's discuss what is an equatorial point. These are two charges, plus Q and that is minus Q. This is the axis of the dipole. A line passing bisecting the axis of the dipole is called its equatorial axis. Any point lying on this line, either upward or even downward, is known as its equatorial point. So we have to find electric field due to this electric dipole at its equatorial line or equatorial point. So consider this is the point P. Okay, and the distance of the point P from the center of the dipole O is R. Clear? Now join these lines. This is A, and this is R. So obviously this distance will be equal to R square plus A square using Pythagoras theorem. Now we'll come to the section of components of electric field, because electric field is a vector quantity, right? So this is a positive charge. This charge will produce electric field at this point, but pointing away from itself. That is along this line and pointing away from this. So this is electric field produced by E positive. What about the electric field produced by the negative charge? This charge will produce electric field towards itself. That is, this is the electric field, or it is E of minus. If you are very much clear in the figure, then mathematics will become very, very simpler. Okay, now suppose this angle is theta. Now this is a line parallel to the axis of the dipole, and if this is theta, then this must be theta, because the two sides, that is AP and BP, are equal. Now this electric field E plus, obviously this angle must be theta. So this electric field will have its component, that is axial component, this way, that is E plus cos theta along the axis of the dipole, and this component, this part, will have its electric field horizontal component along the x-axis again, because this angle will again be theta, because this is theta, so this should be theta. You know this why. Now this is the horizontal component of this electric component, and its perpendicular component will be this, that is E plus, but perpendicular means sin theta. This E minus has one component along this direction, that is, it is denoted by E minus cos theta, and its perpendicular component will be downward. So this is equal to E minus sin theta. Now be sure of the components. This is the horizontal component of field produced by plus charge, that is this E plus, and it is the horizontal component, the second arrow, horizontal component of the electric field produced by the negative charge, right? So both are in the same direction. So obviously they must be getting added, as we did in case of the circular ring. Now remember, the perpendicular components being equal and opposite, they will be equal. Why? Because the two charges have equal magnitudes, and the two charges are at the equal distance as well from the point P. So they must be producing the same quantity of electric field. However, the direction are different. So the components being equal and opposite will cancel each other. So this is the figure. That's the very important part of this derivation. So first we shall calculate the E plus. equal to E minus, it should be E minus because both the charges are plus equal magnitude and at the same distance, and this is given by 1 upon 4 pi epsilon naught charge, any of the charge, and the square of the distance, and this is the AP or BP. So obviously square of this distance is equal to R square plus A square, and this is the magnitude of electric field at this point due to the two charges, and let's assume that is E, right? So from the figure it is clear that the horizontal component, from figure the horizontal component of axial component being in the same direction are added, and the perpendicular components being equal and opposite cancel each other. Okay, obviously it means this part and this part has no role to play. We shall only deal with these two components. So the net electric field, E is equal to what? E of plus cos theta plus of E minus cos theta, and E plus and E minus both are equal and have been already taken as E. So we have, this is E cos theta and again E cos theta, that is twice of E cos theta. That is, suppose this is net electric field E, I put a subscription over T. E total equal to twice of E cos theta, where E has its central value. Now, what is the value of cos theta? Cos theta is equal to, come to this triangle O, B, P or any of the triangle, cos theta is equal to base upon hypotenuse. That is, cos theta is equal to half of the dipole axis, that is A over hypotenuse under root R square plus A square. Then say this is equation 1, and E of total is equal to twice of E. Twice, what is the value of E? This, Q upon 4 pi epsilon and R square over A square, right? That is the value of 2E. Now cos theta equal to A over R square plus A square, right? Equal to twice A cube upon 4 pi epsilon naught, and its power will be half. So this goes to R square plus A square to the power 3 by 2, and this quantity is equal to dipole moment P, that is P over 4 pi epsilon naught R square plus A square to the power 3 by 2. That is your total electric field equals to, this is power 3 by 2, right? Now what if the A is very small than R? Then obviously again we shall discard this quantity A square. So E of T is equal to P upon 4 pi epsilon naught R square to the power 3 by 2, because we are already taking A square equals to 0. So this 2 cancel this. So P over 4 pi epsilon naught R to the power 3. Right? This is again, E is proportional to or varies as the third power of R. So earlier we had an axial point, that is twice of P. Now we have in the numerator only P. It means the electric field at the equatorial point will be half of that produce that axial point. That is E axial over E equatorial is equal to what? 2:1, or you can solve this twice of P 4 pi epsilon naught r to the power 3 upon P over 4 pi epsilon naught r to the power 3. Everything goes cancelled and we are left with 2:1. Okay, the most important part of this derivation, which is quite commonly asked in exam, is its diagram. So you should be very much efficient while drawing this diagram. Again, look at this. This producing electric field and the positive away from it, that is E plus, which has component E cos theta and E sin theta, and this produces field towards itself, that is this is E minus, and its component, one will be along the previous component, horizontal component, and other will be perpendicular but in opposite direction. So the perpendicular components being equal and opposite cancel each other, only horizontal components get added, and that's why we have chosen E cos theta plus E cos theta. This is the important addition, and if you've done this, then you are done, no problem. So the rest of the calculation is quite easy. Just be focused and do it. Okay, till then, bye.